Hello, welcome to this lesson. In this lesson, we talk about second order non-homogeneous recurrence relation with constant coefficient. Okay, so now second order non-homogeneous recurrence relation with constant coefficient are of the form okay, S not A subscript n plus 2 plus s1 a subscript n plus 1 plus s2 a subscript n equals to f of n. That's a function of n. You see, for the homogeneous part, for the homogeneous recurrence relation, our f of n is always 0. Okay, now when you have a non-homogeneous recurrence relation, then the solution is given by this. We have two terms. Our k of n is the complementary solution, which is the same as the solution to the homogeneous part of this problem. So solving for k of n, you solve only the homogeneous part. That's, you set f of n to 0. Then for the particular solution, you check the nature of f of n. Then you try to find p of n plus 1, p of n plus 2. Then you substitute it into this equation. Then you proceed from there. Okay, so let's solve an example. Okay, so we have this problem. This is a typical example of non-homogeneous recurrence relation. So for this problem, our f of n is what? 3 times 2 exponent n. Okay, that's our f of n. So first of all, we find the complementary solution. The complementary solution is just the solution to the homogeneous part. So we set our 3 times the right hand side of the equal sign to 0. Okay, then we use the normal method. We let a subscript n to be lambda to the power n. So when we do that, it means that our a to the a subscript n plus 2 will be lambda to the power n plus 2. 3a to the subscript n plus 1 will be 3 lambda exponent n plus 1. Then this will be 10 lambda exponent n. But you see, when you have lambda n plus 2, this is the same as lambda squared times lambda n. And the second term, when you have lambda n plus 1, that will be, it's just the same as lambda times lambda n. Okay, so you realize that lambda to the power n is a common factor. Okay, so we factorize it out. So on the first term, when you factorize lambda out, lambda to the power n out, on the first term, okay, on the first term, lambda to the power n will just cancel lambda to the power n, leaving lambda squared. Okay, so that's what we have. Then on the second term, when you factorize lambda out, it will be left with just lambda times 3, which is 3 lambda. Okay, that's what we have here. Then when you factorize lambda n out, the last term will be just minus 10. Then we equate to 0. But we know that lambda to the power n, okay, that's your roots to the power n is never equals to 0. And since this is not equal to 0, it means that lambda squared minus 3 lambda plus minus 10 is 0. And when you solve this, you're going to get 5 and negative 2. Okay, when you solve this, you're going to get 5 and negative 2. And therefore, our complementary solution, which is kn, okay, is given by this. Don't forget, when you have distinction, the solution is given by c1 lambda 1 to the power n plus c2 lambda 2 to the power n. So our lambda 1 is 5, our lambda 2 is negative 2. Okay, so now we solve for the particular solution. So for the particular solution, we consider the right hand side. Okay, so for this particular problem, the right hand side the right hand side is given by 3 times 2 exponent n. This 3 is arbitrary constant, so we can let real of n to be any constant, okay, a times 2 exponent n, okay, and therefore if you let real to be a times 2 exponent n, then our real, this real of n, then our real of n plus 1 is going to be this, and our real of n plus 2 is going to be that. Then we substitute real of n plus 1, so we substitute real of n into, so our real of n will replace a subscript n, our real of n plus 1 will replace a subscript n plus 1, then our real of n plus 2 will also replace a subscript n plus 2. So when we do that, we obtain this equation, okay, that is a times into bracket 2 exponent n plus 2 minus 3a into bracket 2 exponent n plus 1 minus 10a into bracket 2 exponent n equals to 3 times 2 exponent n. Okay, and we can factorize 2 exponent n out, and when we factorize 2 exponent n out, this is how we are going to do it. 2 exponent n plus 2 is just like 2 squared times 2 to the power n, and 2 squared is what? 4, so you get 4 times 2 to the power n. So 4 times a is what? 4a times 2 to the power n, and 2 exponent n plus 1, 2 exponent n plus 1 is just like 2 times 2 to the power n. So we can multiply that 2 by the 3a, so that's how we obtain this 6a. Okay, then the last term we have this. Okay, so in all we can factorize 2 to the power n out since it's a common factor. When we do that, we get 4a here minus 6a there, then also have 10a. Okay, so now when we obtain this, our right, you see we have 2 to the power n on both sides of the equal sign, so they can cancel out. Okay, they cancels out, and when you do that, I get 4a minus 6a minus 10a equals to 3. Okay, and when you simplify this, you see 4a minus 6 is negative 2a minus 10a give you what? Negative 12a equals to 3. When you solve for a, you get what? Negative 3 on 12, which is negative 1 over 4. But our real is given by what? Our real of n is given by minus 1 over, real of n was what? A times 2 to the power n. Okay, so now we have our a to be minus 1 over 4, so we replace it there, and this is the same as, we have minus 1 over 4 times 2 to the power n, and this is the same as minus 1 over 2 squared times 2 to the power n, and this can also be written as minus 2, that's from the laws of indices. It can also be written as negative 2 exponent minus 2 times 2 to the power n. Okay, and we obtain what? Minus 2. When we add the exponent, you see minus 2 to the power minus 2 is multiplying 2 to the power n. They have the same base of 2. Okay, and if when they are multiplying, we just add the exponent. Okay, so it will just be minus 2 exponent, you see the first one is minus 2 plus n, and this is minus 2 exponent n minus 2. So that's what we have here. So we can now find our general solution. Our general solution is just the complementary solution plus the particular solution. Our complementary solution was this. Okay, C1 times 5 to the power n plus C2 times negative 2 to the power n, where C1 and C2 are arbitrary constant. So when we combine it with the particular solution, we get this as our general solution. I wish you all the best of luck in your studies. Thank you.